All right, let's look at number 3. Write the ground state electron configuration and orbital notation. And, so I'm going to do 2 things here, for each of the following atoms. So number 3, phosphorus, doing ground state electron configuration and orbital notation. Since we covered orbital notation first in class, let's do that one first. Okay. First thing I need to do is look at the periodic table and see that phosphorus is number 15. And that means it has 15 protons. And because right now we're assuming that all atoms are neutral, there's no net charge, that means that there are also 15 electrons that I need to account for. So let's fill them up. 15 electrons. I'm going to require at least 8 orbitals in order to fill this up. So those are going to fill the 1s, then the 2s, then the 2p, then the 3s, then the 3p, and that's going to get us as far as we need to. So 1, 2, 3, 4, 5, 6, 7, 8. That's the 9th one. Maybe something will be open, maybe it won't. But we need to get into the 3p sublevel in order to house these 15 electrons. So I'm going to start over here at the left because I need to satisfy the off-bound principle. Go from left to right, lowest energy to highest energy. As I go through, I'm going to satisfy Hund's rule by making sure that I go through and singly fill each orbital before each set of orbitals before I move on to the next sublevel. I'm also going to satisfy the Pauli exclusion principle by making sure that every single electron that fills a particular orbital has the opposite spin when compared to its partner. So here, the 1s sublevel only has 1 orbital. Okay, so it's not like I can really see Hund's rule happening, but I can see the Pauli exclusion principle because each of these electrons has the opposite spin. Now I've accounted for 2 of the 15 electrons. So move up to the 2s. I can put 2 electrons, each with opposite spin, in that single orbital. And now as I move into the next sublevel, the 2p, I get to see Hund's rule in action. I'm going to go through and fill each orbital singly, okay, with a single electron before I go back and double up. Now that I filled them singly, I can go back and double up, still using opposite spins here. So now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons accounted for. I have 5 more. Then I move on to the 3s orbital to get me to 12. You got to satisfy Hund's rule by spreading these out. 13, 14, 15. So this is the orbital notation for phosphorus with 15 electrons. We're not done yet. I need to do the ground state electron configuration. I'm going to go 1s, 2, because there are 2 electrons in the 1s sublevel. 2s, 2, because there are 2 electrons in the 2s sublevel. 2p6, because there are 6 electrons in the 2p sublevel. 3s2, again, 2 electrons in the 3s sublevel. And then 3p3, because of the 3 electrons in the 3p sublevel.